Good morning, everyone. How are you doing today? I hope everything is fine. We had a bit of a technical challenge as we're in a different location today, but we're set. In just a few minutes, we would be running and starting our final day of our training. So stay tuned and please tell your also fellow trainees if they're concerned about us not training, please let them know. So good morning, everyone. How's the weather today around you? Let's keep on saying good morning as we set up our environment. Good morning, everyone. So we finally managed to start the training. I'm quite excited to have you all for the third day of our training. Um, so, so we'll be starting our training in just 3 minutes. Let's start joining. How's your weather today? How are you feeling? Good morning, everyone else. I'd like to understand how you're progressing towards your project. Please go ahead and write down in the chat section and also in the Telegram and WhatsApp group so we can understand how you are moving towards your project. Okay, you can start writing. Okay, so I think a lot of students are already joining us. We're set to start the training. So what we're going to do is let me share my screen. Okay, there you go. Okay, so as usual, here's what we're going to do. We're going to create a new file, a new folder first on day three. On day three, new folder, and that's going to be day 3 code data. I haven't maybe shared you day 2, but I'm going to do. So let me create a new file, and we want to create a file known as seaborn.ipynb, and there you go. We have the file. And in case if you haven't installed Seaborn library, please go ahead and pip install it. So in your pip install, you go ahead and say pip install Seaborn. So this would be installing. Okay, for my case, actually, it's been already installed. It's a virtual environment issue that's happening. Maybe you can go ahead and check if actually Seaborn is working. As usual, what we do is we say import Seaborn, and you select your kernel. Okay, so for me, it have imported. Let me see how many of you have already installed and imported, and maybe we can check out the version of Seaborn. We can say um, um, Seaborn dot version and two underscores, and then you get the version of Seaborn. For me, this is the version that I'm using, and let me see. Okay, I saw installed on my end. I got 2 confirmations. Let me get more. Let me get more of the confirmation that you have already installed Seaborn. Like that. Good choice. You go, sir. Okay. Okay, so I got a couple of confirmations. I can see one, two, three, four, five, 6, 7, 8, 9. We got 9 people who have installed, but I need more. But I need more. I need a lot of people saying if it's already been installed. In case you forgot how to install, I'm going to write the command here, pip install Seaborn. There you go. Okay, for those of you who are just joining, what we're doing is installing our Seaborn library so that we can start working on our Seaborn class today. Um, I'm getting a decent amount of uh, installed. Okay, so that's good. That's good. So I think, okay, I'm going to show one more time for those of you who haven't installed. So here is what you do. If you can see my mouse on the screen, this is the panel that you're going to select to get the terminal. Maybe you can also use Control J or Command J if you're on Mac. And then this will appear. Here, what you're going to write is pip install and Seaborn. So then you would install a Seaborn library. Seaborn library. All right. Okay, so because I want to reserve most of the time of today for your project works, I might have to start. Okay, so today we're going to see visualization. Well, of course, we saw a couple of visualizations that you can be able to do while using matplot library, but a matplot library is not very swift in working with visualization. Well, of course, it does a lot of things, but Seaborn is even much better. And that's why we usually use Seaborn for visualization, even though the fundamentals and the structure comes also from matplot library. So let's import some of the other libraries that are required to do this. So I'm going to also import NumPy as NP, pandas as PD, and also import matplot library.py plot as PLT. Okay, now that I have imported my library, I'm going to start working on Seaborn. So for us to have a simple data usage, what I suggest we do is use a dataset that is already available in Seaborn, and this dataset is known as tips. So tips dataset is already available. So what we can do is we can create a variable that's known as tips, and we're going to import it as SNS because I don't know how. Oh, so I haven't written a short form of Seaborn, so I need to say it Seaborn as SNS, right? So it's much easier to use it later on. So SNS dot load dataset. See, this is a dataset that is already in Seaborn, right? And for educational purposes. So there's a dataset which is known as tips. So tips is a dataset that you can use and mostly important for, the dataset includes, like if we go ahead and see what the dataset is, the dataset includes the total bills in that specific restaurant that you've used, and also the person's name is not there to keep the data anonymous, but then there's a total bill of that data, the amount of tip that person have left after a meal, and the gender of that person. Is that person a smoker or not?
and which part of which week, which day of the week actually was this, and was it dinner, breakfast, or lunch? And there's a size. The size is the amount of meals. Is it two meal or the orders? Generally, it could be just a coffee or two coffee or three coffee. So we'll be analyzing this together. So how many of you are set in importing this data set? I'm going to um, copy this and send it to you both in Telegram and WhatsApp group. Okay. Um, no, the video did not freeze. I'm actually waiting for you to do this. And some of you who would like to come in person, we are still in person. And if you had a connect, I mean, if you're unsure of where the location is. You have to come to Arat Kilo, and then you have Ambassador Taxi, and inside the ambassador, you drop off at Innovation Minister. Or else, if you're coming from Bole, maybe you can have the Piazza Taxi. You can drop off at Ambassador and pick up the Arat Kilo taxi, and then you can move on to dropping at Innovation Minister. I've sent the pin in all the groups, and if you have any challenge, you can always write down. Okay, how many of you have loaded the data sets? Of course, you need to install Seaborn. I'm getting an error when it comes to loading the data set. Maybe can you check on the code? Can you check on the code? Repeat once again, said Job, what do you want me to repeat? Is this the location or is this the um, the lesson? Let me know, Job. Okay, I got a lot of loaded. I think I got 1, 2, 3, 4, 5, 6, 7, 8. Usually when I get 10. SNS could be a problem if you haven't originally written it as when you import as an SNS. So maybe I'm going to copy this and also send you the code. Okay, this is the way that you need to import it in case if you're having a trouble, that might be the case. Once that we have imported our data sets, okay, the data is loaded, but I don't understand where the data actually comes from. The data comes from inbuilt Seaborn datasets, okay? Seaborn by itself does have a couple of datasets that are inside um, uh, Seaborn. But for your case, as we saw yesterday, you need to import your data as Excel file or as a CSV file, and then you can import it using pandas. Okay, this is just a library of datasets inbuilt in Seaborn. Okay, so a first thing to do when you start to check your dataset is to check the head of the dataset. So what I can do is head meaning like the top section of your dataset. So I can say tips.head, and that gives us the head of the dataset, which means the top three elements. I think four or more. Hold on. Oh, this is just the dataset that is being the whole one. But for the head, it shows us the top five elements because this is the index and it starts with 0. It goes until 4. But it can also define the amount of head that you can see. For example, I can say 3, and then it shows me the top 3 data sets, 0, 1, and 2. So this is how our data set looks like, and we can start drawing some graphs to visualize what we can be able to do. For example, let's see a histogram plot. If you remember from previous day, histogram plot is a plot that actually tells you um, um, what the amount of distribution in your the amount of the frequency of distribution of each element. So whenever you want to do SNS plots, there are a lot of plots that are integrated with SNS. So you can see that when I say SNS, there are sets of plots that come. There are bar plots, there is a box plot, and a lot of them. So let's go ahead and test a few of them. So maybe I can start with histogram plot. So the syntax for it is hist plot. So I can say then give the values that you want to do hist plot. So maybe we can start off with the total bill. So not to cause a spelling error, I'm going to copy the column. First thing is always when we plot, we need to give the data of the plot that we're going to do. So this is the column. From tips, I have selected total bills. And I'm going to do beans. Beans is the amount of size of elements that the amount of beans that you would like to see in your histogram. So this is how it looks like. Maybe let me zoom out a bit so that you can see it better. So this is the histogram plot. You can see that a lot of the cluster of the total bills from that restaurant lies on 15 to 20 a month, maybe 10 to 20 is the amount of dollars that is getting paid in that restaurant a lot. So maybe there is a specific meal later on your explanation of in the afternoon. What we're looking for is like as we see this graph is explaining the amount of total bills in a certain restaurant that's known as X, and in that restaurant people are consuming a certain food and they're paying 10 to 20 USD. And this meal might be one of the special meals in the house. That is the explanation. So, as a business strategy, because ultimately what we're looking for from a graph is maybe for a business case or for a research case and do some interpretation. So ultimately for a better benefit and for a better knowledge. So if it's a business, then you can pick up the points where there's a lot of the time that if 10 to 20 USD are getting spent, and maybe that foods you can specialize better and have better income. So this is the type of explanation that we're expecting in the afternoon. So this is a way that you can do a histogram plot, but also let's try and do more plots. And you can also do like tips dot describe. Maybe I haven't showed you about this previously in the previous class. So the describe function in a data set is important. You can also do the same thing in pandas as it's a data frame. So it tells you the descriptions about the data. So for example, how many columns does the total bill have? It have 244, how many rows? It has 244 rows. The same is true for tips and size. And also, what's the mean value? The mean value of all the total values is 19.7 and 2.9 for a tip, and the size is 2.5. And this is standard deviation. This is the minimum value. The minimum value is 3.07. Standard deviation is the deviation from the mean, the amount of value that the data deviate from the mean. That's 8.9. And we have the 25% of the data is at 13, while 50% of the data is close to 70, and 75% of the data is around 24. And the maximum value is 50 USD. So describe is a way that you can describe your data set in just one shot. And you can be able to explain and make a realization from this. So in the afternoon presentation, we're not really interested in you explaining the code, but the visualization, the interpretation of the data is what we're looking for to listen, right? So be aware of that, use your time effectively. Okay, now that we have described and done a bit of visualization on our data, we can even do some better plots. So one of the important plots that you would like to use is the joint plot. So joint plots are plots that are useful whenever you want to actually compare two sides of a data. For example, if I wanted to check SNS dot joint plot, I can give it two data sets, two columns. So before I provide the column in the syntax of joint plot, what I do is I give the total, the whole data. This is tips. In your case, it could be different data. So for the X, I'm going to give it one of the columns. Let's try and check the tips, the total bill and tips. So to understand the relation between total bills and tips. Whenever the total bill is higher, does people actually pay higher? Let's try and understand about this. Total bill and Y equals to tips. Right? Let's go ahead and run this. Voila, we have an error. Could not interpret tips for Y. An entry with this name does not appear in the data. So I think I misread the data name. Let's go ahead and check what the column's name is. So it's tip, not tips. The name of the data is tips, but that column is actually tip. So I'm going to improve this to be tip. Okay, there you go. This is our graph. Let me zoom out a bit. But for you also to write the same thing, I'm going to send you the code. I'm making the screen smaller. I understand that it might be difficult for you to see, but it's okay. I'm going to send you the code here, so you can check it out. Also on WhatsApp, also on our on the chat. I'm going to also send it on the chat. There you go. So as you run this, please send screenshots of what you're doing on both Telegram and WhatsApp so that I can check. Okay, the first graphs code. Okay, let me go ahead and share that as well. There you go. I put it on the chat. So it's much easier for me to put the codes on the chat. So I'm going to mostly put it on the chat. You can also always find it from there. Okay, let's try and interpret the second graph. So the second graph is a distribution plot plus a scatter comparison of two a distribution and a scatter plot of two data sets. Look, so here, this is total bills. And this on the y-axis is tips. So you can see that the distribution of tips is clustered around 2 to 4 USD, while the distribution of total bill is clustered around 10 to 20. That's what the sidebar graphs or the histogram plots show. But as you can see from the scatter plots, a lot of the scatters are actually clustered around 10 to 20 as well. So you can understand or interpret to be whenever the data set, whenever people pay less, there is no tip. And also you can understand that people that are paying a lot of bills are not giving tips. And on average, people that are 10 to 20 USD consumers are the ones who are actually giving tips. And that's what the data set is telling. But you can also understand that whenever people that are consuming much or paying a lot amount of bills, like above 30, 40, and 50 USDs, you can see that the bill, the tip size is also much bigger, like 10 USD, which is by itself a meal payment. So even though the payments are not, a lot of people are paying when there is 50 USD or 40 USD payments for the meal, but whenever they do give tip, the tip size is much bigger. So people that are consuming a less lot amount of meal or anything from the restaurant, they tend to pay less amount of tips. And you can see that there is a cluster of tips here. So when I'm trying to explain how the graph actually is scattered. Each point means each data set. For example, if you go ahead and count, it's mostly each point of data that we have. But make sure that your data is actually not skewed before you make any explanation. This could be the case that most of our data is actually towards 10 and 20, USD payments, and we do have a less amount of $40 and $50 USD payments for their meal. That could be the case, and in that case, the explanation could be completely different, right? So your interpretation should be very valid. Otherwise, you're misleading someone else. So this is the type of explanation that I am interested to listen in the afternoon, really. Um, I'm not sure. Okay, let's have a bit of a discussion regarding some of the questions, but that interpretation seems like it's not accurate. It could be. It could be. I'm just trying to make an interpretation. I'm not doing a research on this, and I'm trying to explain what the graph could potentially say. Afomia said it's cause people usually spend from 30 to 30. Exactly. That could be the case that a lot of people are actually tipping there. That could be one very valid explanation because our data is actually clustered towards 20 to 30 BLs. Okay. Thank you. Okay, Afomia, you already got it. Okay, great. So, um, there was one thing that I wanted to say. So as the amount of data increase, it's a bit challenging for you to find the places that are dense amount of data or patterns. So you can add to your code here. I'm going to send out the code again so that it's much easier for all of us to visually see the graph. So I just said comma, and then I can say kind, and then I can write down hex. So if I do this, now you can see that the bars, the dots have been changed into a hexagon. So the hexagon color gets denser and denser as as the amount of data is quite clustered. You can see that a lot of the cluster is happening around 10 to maybe 18 USDs even. And you can see the clusters getting lighter and lighter as there are less amount of dataset. I mean, patterns. So let me go ahead and send out these whole code, and I would like to see how you've tried to achieve what we're doing. Okay, then I've sent it on the chat. Also, let me do the same for you in the Telegram and WhatsApp group. Okay, so I can see that a lot of you have already started working on this, and there is a lot of visualizations that are exciting to see. I'm seeing a lot of you try to do this. Excellent. That's quite excellent. So I'm going to also send out the morning attendance um, for the community in both WhatsApp and Telegram group. And also I'm going to do the same on the stream on YouTube. So please make sure that you fill in your attendances in using the link. Excellent. A lot of you have already tried to work on the histogram plot with using beans, and even exciting works from Talemo. I'm sorry if I'm saying your name incorrectly, but you've even added colors to the scatters, and I believe that that's interesting. Can you also share the code that you've written so that other students could also try and work on this? Okay, I could now proceed to, usually when you start working on your data set, the best way to start is using pair plots. So pair plot is a plot that you can use to actually see the relation between all the data sets together, all the columns. For example, we have 4 or 5 columns, and we can integrate to see the relation between each columns one another. And this could be very helpful to start to have the first point of your discussion or data. So I understand my code is a bit unreadable because it's small, but I'm going to share you. This is because we want to see the graph a bit better. So what we say is SNS and then pair plots. Okay, you might have a recommendation from the SNS library, and then you give the data. You can just say tips, or you can say data then tips. And then we're going to give it a hue. It's better to explain after after we do the visualization. So for the hue, I'm going to give it the smoker column. And for the palette, palette is the type of color that we're going to use. I'm going to use cool warm. There are a couple of colors that you can be able to use. And for the kind, we're going to use a scatter. Okay, so let's run this. Voila, we have an error. Let's see. I think it's coming from, okay, let's see, tip is not defined. Yeah, it's actually our data set is tips. Okay, there you go. So this data, what it's trying to do is trying to give a comparison between all the columns. Okay, let me send you the code so that you can also write it down and try to check it by yourself. Let me go ahead and share you the code in all our chats and community. So you can see that on the y-axis we have the total bill, we have the tip, we have the size, and also the same is true for total bill, tip, and size on the x-axis. So it's trying to do the relationship between each of the data columns. And hue, what I said in the code as hue, is the smoker column. So is that person a smoker or non-smoker? So if it's a smoker, it's a yes, and the graph is blue. And if it's a no, it's going to be kind of orange, light orange. So you can see that every graph you see here does actually have a color. And for example, let's go ahead and check between tips and um, maybe tips and total bills. This was the graph that we saw earlier, wasn't it? So tips and total bills does have a relationship of as such, where there is a cluster of data around between 10 and 20. And what we added on the top of the previous data set, I mean, the previous visualization, is that we now have a color where the light orange color is representing the smokers, non-smokers, while the blue ones are actually smokers. So it's more descriptive than the previous graph that we saw here. It doesn't really tell us which person is actually a smoker or not. So you can understand that it's almost equivalent amount of users that we have here are actually smokers and non-smokers in this restaurant. So maybe you can use this as a decision for any of your works in that restaurant. Maybe you can create a specific location for smokers so that smokers can benefit still dining in that restaurant without disturbing the non-smokers, because there are non-smokers also taking part, benefiting or in dining in this restaurant. Also, you can see the relationship between tips and tips, that it's showing a Conrail density kind of function. So Conrail density function tries to draw a graph and tries to give a strong emphasis towards the density of the data where it exists. For example, let's see the smokers. So this is the blue graph, and you can see that a lot of smokers are spending around 10 USD, around 10 USD. If we see actually it says oh, this is a tip, so 0 to 5 is the tip, so it's around 2 USDs of tips are happening by smokers, non-smokers, yeah. But we have better amount, the amount of tip is actually closely related, but I think non-smokers are giving um, more amount of tips. I mean, more non-smokers are providing tips, even though the tip amount is something similar. But generally, what I need you to do is try to understand what the graph is actually saying. So pair plot, what it does is it plots each of the relationship that you have between your graphs. So you can actually have a better understanding of your data, and then you can zoom in two columns as we have done the joint plot and everything. So let me see if how many of you have actually tried to work on this. Let's go and check. Okay, that's excellent. I can see that a lot of you are doing it. As you keep on plotting, also make sure that you fill in your morning attendance, so that you're not considered to be absent. Okay, let me give you a few minutes to try and test this, and we are going to then move on to a couple of more graphs, and today's section would be closed. In terms of teaching, and the rest of the day is going to be yours until 2 p.m. in the afternoon for you to start to develop your projects and everything, right? Okay, I'd be seeing your works. Let me give you a timer of 3 minutes to try and do this. I understand you'd be having your break in 2 minutes, but what we're remaining is just a few minutes of work. So maybe it's better that we just complete our section and okay. I would be on Telegram and also in the chat if you do have questions. Okay. So so I can see that most of you have tried working on this. So make sure that you don't forget your attendance. Attendance has been sent out. Please make sure that you fill in the morning attendance. Afternoon attendance would be sent out in the afternoon. Okay. Um, let's go on. So you might as well do other plots to check your categorical features, which which could be interesting. Um, you can also do one interesting plot, which is known as the rag plot. So rag plot is like a plot that is showing the density of a certain data column uh, as a rug. You know, rugs are mods, right? So rug is something that you step on, right? When a rug is denser, it's much beautiful, and when the rug is actually, um, uh, you know, when the furs of the rug go away, then it's not so beautiful. So this is the motivation for this graph. So it's tips. The data name is tips. So you can see that the rag plot here, it shows each data point as one line. And whenever we have a cluster of data around, that means this is the point that we have a lot of our data set. So I'm going to also send you this code for you to try it. There you go. Okay. As you also try that, I'm going to show you more plots that you can be able to use in your project, in your specific data set. You can also use the Conrail density function, which I've been mentioning a lot. KDE is trying to show the density of your data as something that looks like line graph, but an area inside of it. That's what we call KDE plot, and it's known as Conrail density function. And you might as well know it from your math or probability lessons. So the total tip is what I want to draw the graph with. And I'm going to give it, yeah, let's just see it first. And I have an error. Total, oh, I said total tip, it's total bill. Okay, you can see that this is the Conrail density function, again showing the density of our data. You might as well give a color to the graph inside as showing shade equals to true. Now you can see there is a shade inside of it. So sometimes there could be a warning. A warning is not an error, but something that you should be careful. So it sometimes shows you that, and it's really okay. This is a Conrail density function, and I'm going to also share you the code for this. Later on, I'm going to share you the whole file as a zip file, so you can always rework on it. And yeah, I'm happy to see that some of you are doing excellent graphs already, and that's amazing. On a WhatsApp group, I can see that a lot of graphs. So let me complete my class faster and then leave the time to you so that you can be working, discussing, brainstorming on what the graphs actually mean. And ultimately, we're using graphs for business decisions. If you're a product developer or software engineer, would like to integrate the graphs to make, two basic things. The first is the new product development, or else business decisions in the product. Which feature do you want to focus? Do you want to focus on on the mobile app or on the web app, because if you focus on both, that could be costly, and you would like to focus on one of it and also focus on the features that are being used by the user and everything. So you might as well find these types of data online, e-commerce data, and then you can also be able to work on this. So you can also do SNS bar plots, which we have done using a matplot library. So you need to give it X. For X, I'm going to give it sex, and Y, I'm going to give it total bill. So is it male or female that is spending a lot of their um, a lot of money on in the restaurant. So I gave it the data is tip, and X and Y is total bill. By the way, if you actually identify what the parameter name is, if you flip them, it's really okay. I can write data and I can write it at the beginning or at the last. Because I have identified the parameter name, then it's really okay for you to not follow the steps. But if you're not writing the parameter name, then you might write datas first, like tips first. So you can see that in this restaurant, a lot of total bills are coming from male than female, but very close, very close. You can also do a count plot, which is something very similar to distribution plot, but I mean frequency, trying to histogram plot, but necessarily it just gives you the count of values. So I can say count plot and give it a value of X, the data that we would like to count, and that is sex, and the data is tips, and we can go ahead and run it. Let me see my error. Oh, since this is just a data and a variable, and we don't want to make it string. Okay, so you can see that we have more male visitors to this restaurant than female visitors, right? So that might be the reason why we are actually having more total bills that are coming from male than female. I'm going to send you all the codes all at once. And this is one very important plot that I can show you. This is known as the box plot. And maybe I can run it first. Box plot. Box plot. And I give the data is tips, and X equals to maybe days, day, and Y equals to total bill. Okay, let's run this. This is what we refer to box plot. Maybe let me copy this, and maybe let me send you the code first for the box plot so that you can also do your visualization. Okay, so let me copy this.
this box plot and put it on my whiteboard. Okay, let me bring in my pen. Okay, so you can see that from the box plot here, so this point that you see here is the 25% of your data set. And while this point is the 50% of your data lying. And this is the 75% of your data. So this is the beginning, the smallest data, and this is the maximum data. But these are considered to be outliers. Okay, outliers. So outliers mostly don't define uh, what your data is actually providing. It's something that usually to be an outlier. So we would like to sometimes remove outliers if it doesn't really have a statistical strong meaning. So this is a box plot, and it gives you a sense of what you have in your data set. For example, in this data set, you can see that 50% of the data is actually between 10 and 20. That's close to around 16, right? And depending on the part of the day, it actually differs. You can see that on Sundays and Saturdays, the total bill have raised a bit. The 75%, the 50%, and also the 20% have raised. Saturday and Sunday are close, but Sunday is a very bit bigger. You can see that the 50% is even bigger, and also the 25%. This shows that, of course, people are spending their time in a cafe, eating, having fun whenever it's Saturday and Sunday, because it's a family day, friends day, and everything. So this could be one explanation that you could do. Even you can see that on Saturdays we have the minimum of the minimum, right? The minimum is very low, as you can see it from a graph. It's very low, the minimum. This could be the case that people are just coming here, just ordering a cup of tea and just staying for their Saturday. Um, yeah, that could be the case, but your explanation could be something very different. And you can see that the maximum values have also raised extremely higher if you consider here the previous day. That's because people could come as a group and spend better. Yeah, these are the things and the type of explanation that you could do for your project. So in the afternoon, just to remind you, we'd be expecting uh, two things. One is the graph, the code, plus presentation. So the presentation should be very small. You should present in 2.5 minutes, and also demo maybe your graph in 2.5 minutes. So you generally have 5 minutes for everything, right? So we'll be calling out names. And actually, we decided, instead of making it random, we would start with group one, okay? Group one, and then group two, group three, we'd keep on going until group 23. So if I say group one at the beginning at 2 p.m., and if you missed, then you missed, right? So make sure that you're ready with your slides, and also select the presenter who's going to present, and make sure that the presenter have a good stable internet and audible and everything. So we're going to send out the StreamYard, and right away we could be moving to our presentation. So before 2 p.m., we're going to send out a
form. So you'd be sending the name of the presenter and your slide and code before 2 p.m. So 15 minutes before that, we're going to send out the for group work, group project. Let's do. We can also add a few things to the box plot, like giving a hue. For example, let me just copy this code, recreate it here, and I can just add a hue to this. A hue to this. So what it means is adding additional set of comparison. So for the hue, I'm going to make it smoker. So you can see that now I have two box plots, smoker and non-smoker. You can see that on Saturdays and Sundays, mostly the consumers are not smokers. Instead, they are non-smokers. Oh, actually, they are the smokers. The smokers are the more consumers, while the non-smokers are the less consumers. Yeah. And you can also do a violin plot. Violin plot is something like a box plot, but more descriptive elements are there. So violin plot, and I give it the data, which is tips. X is, let's say, day. The same thing that we've done for the box plot. Y is total bill, and hue is, let's make it sex. I have error, invalid syntax, maybe, okay, I have double equality somewhere else. Data is tips, X is equals to day, Y is equals to total bill. Oh, I have a double bracket here. Okay, so this is a violin plot. So violin plot is something that adds up to kind of a box plot. You can see that the Conrail density function is also running sidewise, telling you the density is around here, and also showing on uh, how the data is getting less and less towards the top. So you can see that the density of your data set, and also explaining even more inside of it, as the 50% is the white color that you see, and 25 and 75% are the points of the beginning and the end of that black cluster of, you know, I don't know how to say, the black things inside of the violin plot. And female is the orange one, and male data is the blue ones. So let me go ahead and send you all of these codes, and I want to see you try to actually write it down. So let me go ahead and send you the codes, but you can start trying if you have already okay.
There you go. I have sent out the code in both Telegram and WhatsApp group so that you can put the code in independent code blocks and you can check it out. Let me see some of the questions or remarks that have been said in the chats and try to respond. Someone is saying, I can't see your screen. Can you please confirm that my screen is visible or not? Maybe that it could be that person's challenge, but let me know if my voice is audible and you can also see me well. Yes. So regarding the presentation, so with every group would have 5 minutes, a very strict time, okay? Very strict time, 5 minutes, and would start with group one until the last group. So 5 minutes, and I'm going to stop you. I understand that could be a bit rude, but we don't have time because people are here, would also come here to listen to your presentations. So make sure that you are quite ready for that and doing things very swiftly. So make sure your slide is ready and also your code. So necessarily you can just present the slides because for the case of the presentation, we're not interested to see the code, but you're going to upload the code, which we are going to check it out and grade you later after the training. So we'll be checking the code individually, but for the presentation, all we want is trying to understand your interpretation. We want to enjoy your interpretation and graphs that you've done. So that's the most interesting part of the training. So please go ahead and start working on this. Um, Yeah, it's visible but small. My screen is smaller because I wanted for the graphs to be visible. That's why the text are very small, but I'm sending out the text in both Telegram and WhatsApp group. So yeah, that's why. So you'd have 5 minutes for your presentation. You might divide it the way that you like it. So you can just go ahead and present the codes generally. Okay, generally. You don't have to say importing like all the logics, the for loop, the while loop, and everything. You don't have to. You just could go roughly over the code blocks. And then presentation 2.5 minutes. That's my suggestion, but generally you can freestyle the way that you want. All you have is 5 minutes, right? All you have is 5 minutes, and do a couple of the things that we did now, and I'm going to leave you to your projects. Let me give you a few minutes to check your questions. Yes. So regarding time zone, we would keep on using the East African time. You can translate it to your time in any part of the 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 world that you're actually taking part in this training, because I cannot tell you what time it is in each country. That's going to create a significant confusion. We have students from Botswana. I understand there is a time difference between Ethiopia, and also there are a few students from Liberia, South Africa, and India and Italy. So the time, there's a 1 hour, 2 hour time difference ahead and behind. So you might change it to your specific situation, right? That's something much better to do. Regarding the zip file, I'm going to zip all 3 days of code and send it to you, right? So I'm going to do that right away. So the training is going to start 2 p.m. GMT plus 3 East African time, Ethiopian time.
Okay. Some of you are asking mentors, group 10 mentor is absent. Okay, maybe I'm going to join you to actually support on that. But if you don't have mentors, your mentors is absent, I really suggest that you start working on the project that you as a team have decided, all right? I might be running here and there. Yeah. So, um, so there would be a question that is going to be sent out on Instagram and as a as an activity both on Instagram and on LinkedIn. I'm going to share you the questions, and we are going to collect the names that have answered. Okay, so I've sent you the links. I'm going to post the questions in just a bit. Yeah, so please go ahead and answer the questions there. Um, yeah, so this should be the end of my session for today. Later, we'll be having our presentation. So we'll be blocking our time for you to start to work on. I'll be sending questions, but also I'm going to support you online. Yeah, that should be the end of today's section. Oh, regarding synthetic data, someone said synthetic data. So synthetic data are not something that we want to see. We want to see real data, right? So never use synthetic data. Find a real data, a real data set. And for some of you maybe who haven't heard about the summer boot camp, and we're having a couple of questions. So let me just go ahead and answer. So you can just go ahead and register from the summer.infinova.tech. You can have all the descriptions there. Some of you asked specific slots of the training time. Okay, we are going to include that in the site. Which time, which training would be provided. We're going to do that today. So the bootcamp, to explain, because most of you are asking, so for the training is going to start on July 19th and July 20, and it's going to be until August 30th. It's going to be a 6-week training. For example, for the data science, you've just learned 3 days, but this is going to be 6 weeks, and it's going to include a lot of things, including even machine learning and working with real data, and also you're going to learn some of deployment things like GitHub and everything, so that you can have a good portfolio. Ultimately, what we're looking to provide you is for you to be job ready, and for whatever that you're working on, giving you the skills that you can work on for your thesis, for your, if you're a master's or a PhD student, and also if you are analyst, if you are economist, if you are working in monitoring and evaluation, these tasks could be quite important in your journey of jobs. So this training is that job level, and we're going to start from the very beginning and go in a slower pace than this training, because this is a 3 days training. But for that one, we're going to cover Python and also give due attention for each of the libraries. So the training is going to be 3 days per week, and online mentorship and support will continue to go on. and it's going to be three tracks. One is the robotics and hardware training, the other is data analytics and visualization, and the other is going to be uh, data science. Yeah, the other is front end web development. So front end, we'll be starting from the very basics: HTML, CSS, and JavaScript. We'll teach you how to make your site mobile responsive, and also GitHub version control, and also you'll be learning React. For the embedded systems, we'll be covering electronics, Arduino microcontrollers, and also how you can be able to realize your story of hardware into actual hardware. This is something that you can learn. And the other is data analytics and visualization. In this one, we'd start off with Python syntaxes, like the basic ones, go complete that, and then move on to data analytics libraries. But we'll dive in deeper and for you to understand a lot more better in depth. And also introduction to AI and machine learning. A few of machine learning algorithms would be covered, like if you would like to do logistic regression or categorical features, categorical regressions using logistic or regression, linear regression, KNN, SVM, and some of these decision tree libraries, also random forest would be covered. Yes, so yeah, that would be everything. Okay, someone is asking for a LinkedIn link. Let me go ahead and share you the LinkedIn link. Okay. There you go. I have sent out the LinkedIn link. Also, let me do it here. Okay, I'm going to send you the code. For regarding the summer camp, yes, of course, you can join the online section. So we'll be having Venus at Addis Ababa University, both are at Kilo and 6 Kilo. We'll be assigning you based on your registration, and also Bole. You can see previous works of especially hardware related topics in our YouTube, and the videos has been here. So you could either choose in person or online. So online would be 6,000 birr, which is quite fair. Also, the in person is also quite fair, 12,000 birr for everything else. In a class. So anyone who's registering in person would also have the benefit of taking online classes. Okay, they would have both in person and online. But for someone who's registering online, then online class is what you're going to actually have. Um, okay, someone said we're done with the lesson start because it was such a great time and experience. I hope we'll continue having this kinds of session during the summer bootcamp. Of course, the summer bootcamp is quite exciting and it's so much fun. That's the best way to end the year at Infnova. Yeah, if you're in Ethiopia, in any part of the Ethiopia, you can join the online training. That's the reason that we are doing this. You can, there are students from Bahar Dar, Gondar, Jimma, and you can learn. If you're an international student, please contact us through the email that we've sent. Also, you can find email address from here. You can contact us to make the payment and everything. You can just go ahead and check out this. Also, you can call us using this number on WhatsApp or direct call. Yeah, the online class is 6,000 there. And also until July, July July 13th, we have 2,000 birr discount for whichever pass that you're registering. If you're registering for the online, that's going to be 4,000 birr for the Ethiopians, and also for the online, for the in-person bootcamp, it's going to be 10,000 birr. But if you're paying after July 13th, then the finance guy is going to call you to actually add 2,000 birr. I'm going to send you the code. Let me answer the questions. Okay, that's finalized all the questions. So I'm going to send you the code, and then you can be able to start to work your class. So when you fill in the form, please make sure that you also select your location, right? Your location that you want to take the course. Okay.
Good afternoon, everyone. So I hope everything is done. It's about time to start our presentations. So get ready. We'll be starting in just few minutes. Good afternoon, everyone else. So it's about time to start our presentation. Joining the class. Can you give me a thumbs up if you can hear me? Can you hear me? Can you hear me? Can you hear me? Can you give me a thumbs up or a confirmation if you can hear me? Good afternoon, everyone. How are you doing? Can you hear me? Hello, good afternoon, everyone else. How are you doing? We're about to start the presentations, and I wanted to know if you guys can hear me well. Can you hear me now? Can you hear me? Okay, so we can now start our presentation. I believe everyone is ready. So let's start off with group one. Uh, Group one shall start the presentation, and I am going to move on to group one now. So I'm going to send you the StreamYard link to join the StreamYard. But keep in mind that only the selected, the presenters should join, because StreamYard has a limited amount of people that could actually join for the training, okay? So only the presenters shall join the StreamYard. So I have sent in both of the Telegram and WhatsApp group. Going to join, please go ahead and start joining. Group one. Group one. Group one, please join from the StreamYard. Maybe Dave, you can pin the StreamYard link. Presenters, please be ready, because if you are not available, then we have to pass on to the next one. So who's going to be the presenter? Because I can see a couple of people already in the chat. I would like to know who is going to be the presenter. Who's going to be the presenter for group one? Only presenters, please join. Who is the presenter? Maybe assistants also, you can tell us in the chat. Who is the presenter for group one? I'm only going to be patient for the first one, but then I'm going to start to move on a bit faster, right?
He is joining 1 second. Mr. I don't know if it's you or not. When you say me, please write your name down. Can you write your name? I want the person's name. I want the person's name. And then I'm going to start a timer. To move on to group 2. Last call for group 1. Rital. Rital. As you join the button. Yes. Dave, you might as well put him on stage. Okay. You're on stage. Group 1, you're on stage. Okay, so to share your presentation, there is a plus screen sign, and then you go ahead and present. For group 2 and the rest, please be ready because I'm going to pass on very fast to the next one. You're on stage, but you're still on mute. Okay, let's move to group 2. Group 2, who is going to be the presenter? Please tell your name. Okay, Lawrence, your presentation is showing, but you're still on mute.
Hello.
Click on the unmute button.
Hello.
Hello.
We can hear you.
Yes, it's group
Yeah,
1.
we can hear you. Hello. Okay, group 1. You can now start your presentation. I'm setting a timer for 5 minutes. You can go on. Your screen is live.
Okay, well. Okay. Afternoon, everybody. Welcome to Group 1. This is our project is based on digital usage and internet among the youth. So I can hear feedback. I can hear myself twice. Okay, so we have the first slide that shows different countries at the bottom that has the country code, and then we have the percentages of enterprises. So we got this raw data from online. This is from European countries. So overall, this slide just shows how small businesses, which is 10 to 49, shows mostly under 15% are highly digital, and the large businesses are highly digital, which is the orange bar charts. Then we have the second slide, which shows the trend between the years now. From 2016 until 2020, you see that there's a flat line. There, from 20, that's when digital usage spiked. We can see they're using the key on the side. Sweden has the highest, followed by US and EU, and so on and so forth. So we used the pandas. Yes, and the like. Moving on to slide number 3, we have the digital intensity level shows red, which is low, and I think from what we learned using the numpys and matplotlib, we tried to filter out the highest effect rows using the color code as well. So I'd like to believe that uh, the data is presented clean enough to see the trends between the years and the countries. Otherwise, our raw data is over there. It's in CSV, which shows the frequency, the size, and our countries as well. There we have ES, UK, so on and so forth, with the years preceding them. That's it from us, Group 1. Thank you.
And showing insights of countries. That was a great job. So if anyone have questions, remarks regarding these presentations, you can go ahead and say a few words. As we finalize group 1, who's going to be the presenter for group 2? Group 2. Already group 1 is having a good saying, wow, that's a great presentation and everything. So that's a great one. Thank you, Laurette. I'm going to put you off stage. So who's going to be the presenter for group 2? Group 2 calling once. Group 2 calling twice. Group 2. Last call. Who is this? Okay, group 3. Let's move on to group 3. Who's the presenter for group 3? I'm only checking the chat in the YouTube channel. Group 3. Okay, group 2 is full. Please, I have to remove you from stage. They kick the, እንትን በላቸው አውጣቸው ኪክ ዘሞት እንትን በላቸው አውጣቸው ባረካቸው የምናወራው ይሰማል ሚዩት አድርጌው
Hello, Ame.
Uh, Hello. Am I audible?
Nata. Umata. Hello. Yes, you're audible. As you start
Hello.
to
Am I
present, share
audible?
your screen. Uh, pr- Press that plus button at the bottom of your screen and start presenting. So, who's going to be for? Yes, you're audible.
All right. I clicked start presenting. I'm not sure if it's showing on your side. Let me see again. Let me try again.
Okay, as you try and figure out, so here's what we're going to do. So volunteer groups who are ready to present, please go ahead and write your name, uh, group number, and the presenter's name. And if you join the StreamYard, I can put you on stage. May please get settled, put your presentation on the stage, and then I'm going to bring you back. We can see your screen, Ame, but we've lost your connection now. Um,
It's still not showing.
yes, we can hear. We can see now. Please proceed. Your remaining is 2 minutes.
All right. Thank you. I am Ame from Group 2, and we were doing an analysis on a superstore sales. So in our first graph, we did sales versus profit by category. So we noticed that under technology has the highest sales as well as the highest profit, while furniture also having high sales, it had the lowest profit, which was something we felt should be more explored, which is why we then went through the second graph where we wanted to see specifically under each subcategory what was giving us the most profit and what was giving us a loss. So it indicates that tables, bookcases, and supplies were actually generating a loss for the business. And this is becoming more evident in the third graph where we see what causes the negative profit. So in the third graph, where we see the trend across discount levels, we notice that as soon as discount goes to 30% and above, we start seeing a decline in profit, all up to 50%. 50% discount have contributed to the most loss to the business. And then we move on to our fourth graph, where we wanted to see the statistics according to sales by each region. And it became evident that the East region contributed to the highest sales. Oh no, the West region rather, which had a 31.6%, with the lowest region being the South. And then we also did sales distribution by each segment. So we noticed that across the three segments, being consumer, corporate, and home office, there is a $50 average, which indicates that both all three of them have a median order size, which is spanning across $50. So that didn't really show us much disparity. And then moving on to sales by ship mode, we had the standard class showing us the highest sales, with a same day ship modes having the lowest sales. So our closing takeaway is that the business is profitable overall, but that profit is concentrated in a few subcategories, and it's being eroded specifically by heavy discounting on tables and bookcases. That is the end of our analysis. Thank you.
Thank you for the great insights, and especially in a business in different regions, trying to realize how the market and the sales are moving, especially the regional diagrams. That's excellent. And I'm very happy that you have learned to do this. Great job, group two. So we can now move on to group three. You can write down your comment, suggestion for group two. Please leave the chat section once you have presented. Okay, so who's going to be the presenter for group three? Group three. Well done, group three. Who's going to be the presenter for group three? So for the code, once we are done with the training, everyone will be sharing their code on our community so that you guys can work one another together. Who's going to be the presenter for group three? I don't see any names for group three. Keep in mind, I am mostly on the chat section of YouTube, so make sure that you write your name there. Okay, group three, no one I can see. I'm moving on to group four. Group four. Who's the presenter? Okay, studio is full.
So please leave the StreamYard if you're not actually a presenter. So I might have to remove you from the StreamYard so that others could be able to join. If you would like to present as a volunteer, please make sure to actually please make sure that you mention your name and your group so that I can add you. Group 3, you're on stage. You might proceed. You're actually on mute, Isa.
Okay. Uh, am I audible now?
Yeah, you're audible. Can you share your screen?
Yeah, yeah.
Okay, share your screen. Let's use our time effectively. Who's going to be the presenter for um, group group
So
group
please
4?
give me few seconds to upload my slides, right? Few seconds.
Okay. As you
Yeah.
do, okay, group 20, you said you wanted to present. Isakor, please join the StreamYard. Then I'm going to make you a presenter. Others who are not a presenter, please stop joining the StreamYard unless you're a presenter and join whenever the time comes after I said your group name, right? Otherwise, it would be
Yeah.
difficult to manage.
Can you see my screen now, right?
Yeah, you're on stage.
Okay.
Okay, you
Okay.
can go
So,
ahead and present.
so I am Isaiah Sumo. I'm representing the community. So our project is on the Titanic, the survival by age, gender, and that of the hello. Okay. So here we first start with the setting. In the setting, we have to do the where the location where the incident took place. So on the night of April 14 to the 15, 1912, the Titanic struck on an ice block and sank on her maiden voyage. Lifeboat capacity fell far short of the passengers and crew above. So here the graph here we're saying we had 891 passenger analyzed from the data set we collected, and over 38% survived, including women and children first. So here our analysis, we first went on the gender, which served as one of the strongest predictor on the survival rate. So like for the male, oh, and for female, the female, we have about 74% of female that survive on that particular ship. And out of the 577 male, we had 19% survive on the incident, which constituting the 0.9 number from the 577. So basically, female had a higher number in this. The female, more female survive on this particular incident than the male. And the next one will come to the age. The age widening the gap even further. So this incident occurred in the sense that the survival rate was mainly focused on a female. The female survived more than the men. And as you can see this graph, we got the boys under 13, they went down to like 12% of the total number, and the women we have 75 to 78%, out of the total number, and the male as well. So basically, it's telling us that the male, the female, or the female children and that of the adults have huge number in this particular incident of survival. So the key insight on this. So women and children first. So there's a huge there's where we have more people from the women surviving into this incident, and the adult men also. So summary on our presentation. So basically, it's all telling us that out of the total percentage of passenger, like the 100%, we had 38% of passenger that survived on this incident. 74 out of the 38, we had 74% women, 19% men, and the children we have 15% on the average range. The girls have 64, and that of the boys 40. Then when it comes to adult, we have 77 women and out of this 15 men. So basically, out of the total 38, so it is like 100. Now you breaking it down, 74% women and 19% male. So the children, on the average, will have some 53%, and out of 53%, we have 64% girls and 4% boys. So the analysis simply saying that both the female adult and that the female uh, children surviving more than the male genders. Hello, are you getting me?
Yeah, we can hear you. Maybe, uh,
Okay.
yeah. So it's a great insight that you showed us in the survival rates of the
Yes.
Titanic passengers, and this might be due to different reasons, but the support for children and women have actually ignited the more survival rates. Interesting to actually realize these two data. Thank you a lot for your presentation. As the others group proceed, maybe if you have any more to say, you can say. In again, if you have more to say, you can say. Betty,
Uh,
You mean
Thank
you
you for
mean I
the
should say?
thank you for the presentation. Actually, it's very nice and clear. I only want to say, is there some additional charts that you can display rather than histogram? I think there are a lot of possibilities to show the data insights. Other than that, I do not have that much more additional comments. It's very nice. Thank you.
All right. Thank you. Thank you.
okay, thank you. So thank you, group three. Let's move on to group four. Group four, who's the presenter for group four? Please write your name early so that I can put you on stage. Since you have presented, Isan, I might have to remove you. Hello. Okay, so we lost power for a bit there. Uh, as we connect, who's going to be the presenter for group four?
Okay, we're back live. So, who's going to be the presenter for group four? Group four. Who's going to be the presenter for group four? Okay, are you on StreamYard? If you're on StreamYard, okay, group four, you're on stage. You might also share your screen.
Pastor.
Okay, share your screen. Group 18, I'm on stage, can present to, what's your name for group 18? I'm going to make you the next presenter. Unless you tell me, I always kick out people from the StreamYard, okay? Okay, Gadesh, okay. Can you also share your screen so that I can see on the stage, Gadesh? I'm going to make you the next presenter. Group four, you need to be faster. Otherwise, I'm going to proceed to Gadish. Gadish is going to be group 18. Okay, then group 16, group 6, Hermela, you're going to be the next third. Okay.
Good afternoon.
Good afternoon. So I don't see your screen.
Okay.
Then group 11. Okay, I might have to put you down until you get ready. Group 18 is Daraja, right? So Gadish, I'm going to put you on stage. Okay, Gadish, you're on stage. Thank you. Your screen is also visible. You can start your presentation.
Okay, am I audible?
Yes, you're audible. So
Hello.
next presenter is going to be Hermela, the third group. So Hermela, please share your screen so that I can put it on stage right away. You have 5 minutes. You may start your presentation.
Okay, thank you very well, and good afternoon as well. I'm Gadsha from Group 8, and I'm going to present our project, which is entitled as Exploratory Health Data Analysis of patient records.
I'm sorry, can you make your slide full screen so that we can see better?
Okay. Okay, sorry. So I'm starting from outline. Of course, I'm not presenting outline. So we start our data ingestion from just importing, and we have permanently fixed some raw issues, some data issues, and also we have data with around 40 samples, and also have a descriptive which shows that there's no any missing in the data. And This slide profiles our primary demographic split between male and female, and then chart one, which presents that around 52% of our sample is almost females, and it's remaining for 7.5 are males. And also we have another chart which counts side by side using Seaborn bar chart. So which also confirms that we have a balanced baseline sample between female and male. And also this one, it is also explaining about the mathematical mean for each variable. And as you see, the red dashed line displays the mean for every variable: age, weight, height, and also body mass index. And we have also other chart which explains cumulative distribution, and it uses box plot to break down body mass index, and it makes some kind of comparison between the group as well. And we have also this one, which is about categorical distribution. Of course, group comparison between female and male, and it uses actually we have used a violin plot which shows the kernel density and of fatness of patient ages actually, and this explains the overall data spread, which is also remarkably uniform across age, across gender, as you see. And we have also another multivariate interaction between different variables. And to understand how variables just interact simultaneously, we use it a multivariate analysis, and the pair plot matrix explains about the issue between the gender variable. And also we have heat map which calculates correlation matrix between the continuous variables, and as expected there is also strong expected linear relationship between weight and body mass index. And as well as we have also a joint plot regression, and this we have also instilled model stats from using the terminal, and also we see that the display actually explains that there is some kind of flow between the data set, and it is also says the scatter plot of age versus body mass index, which overlays marginal distribution, and a histogram on the top in the right margin as well. And it fits for linear regression line, as you see the line as well, this one. And the positive upward slope allows us to visually model how patient's body mass index is tend to change across different age groups. And that's all our work. And, we have actually moved from raw data to infrared SFP analysis. And thank you very much, everyone, for your time today.
Thank you for the good presentation where you've used a lot of plots and have used joint plots, violin plots, and everything was very good insights and discussion. Thank you for the good work. Anyone who'd like to say words regarding group 18, I think, presentation?
Yeah, group 18. Yes.
Yeah, you might write it down. So if anyone from Nageda or Betty have anything to say, you might add. Otherwise, okay.
Actually, I would like to say thank you. You almost addressed most of the chapters, and you have already cleaned data analysis. I think you are also a data analyst.
Yeah.
Yeah, it shows me like that. I'm not sure your background, and that is very nice presentation. I almost see a lot of lessons from you. Thank you.
Thank you. Thank you. Thank you, Group 18 and the team. So I'm going to put you down stage. Thank you for the good presentation.
Okay, thank you, thank you.
Okay, next up, I'm going to put back Group 6. That's going to be Hermela. Hermela, I'm putting you on stage. Thank you for getting it ready. Also, your presentation is on stage. Okay, you might proceed. But before you proceed, who would like to be the next presenter? I might want two people. Okay, group 5, Marcos, and after that, Marco, and then I'm going to proceed group 5, Marco, and group 20, Isakor. So please join the StreamYard, Isakor and Marco, StreamYard, and then we'll proceed. Hermela, over to you.
Okay, thank you so much. Good afternoon, everyone. My name is Hermila, and I'm representing Group 6. And our project title is Factors Affecting Student Academic Performance. And we used Python to analyze the data and visualize it. Moving on, our problem statement is that students achieve lower exams, but we have no clear evidence which factors contribute to it. So we focused on 4 main factors in this project. We focused on study hours, attendance, sleep hours, and previous academic achievement of students, so that we can explore the relationship between the variables with exam scores, and also to provide a recommendation to help schools tailor their practices. So talking about the dataset, we took the dataset from Kaggle. It is a dataset with 200 students, and it includes variables like study hours, sleep hours, attendance, previous score, and lastly, exam scores. And we did some exploration, cleaning, analysis, and visualization to lastly come back with evidence-based conclusion. So throughout our data cleaning process, our dataset was had no missing or duplicate values. Therefore, it was a clean dataset. And also, we have also viewed some summary stats to understand the distribution within the variables. So let's move on that. So the first distribution we see is the exam score and the study hours. Looking at the graphs, we can see that study habits is varied among students. Different students have different study hours. However, we can see the exam score is somehow relatively normal distribution, making that around 30 to 40 is a common exam result among the students. Now understanding the 2 main factors, we move on to how exam scores are being influenced. The first one is the impact of attendance on the exam scores, and we use the scatter plot, and we can see that the trend looks an upward, and it somehow indicates a positive relationship. However, the scatter plot is not, it doesn't look strong, as the dots are not in close to the line, so we will not say it is a strong predictor for the exam scores. Next up, we're going to see the impact of hours studied versus the exam score. From the graph, we can see that compared to attendance, there is much strong relationship, and the data points closely follow an upward trend, meaning that the more they spend on studying, the more their exam score will increase. Lastly, we're going to see the influence of sleeping hours. From the graph, we can see that average exam score on the number of the sleeping hours, and students who sleep around 7 to 8 hours have generally better exam results. However, since the graph is quite diverse, we can't conclude that. So we can just say there is some influence, but it is less consistent than study hours. Lastly, we have correlation matrix to deep dive into how those numerical factors can correlate, and we can see clearly that the strong driver with correlation number of 0.78 is the study hours, and moderate drivers are attendance and previous score, and lastly, sleep hours has a negligible statistical link to the exam score of the students. So throughout those visualizations and analysis, we came up with some recommendations. We can say that we students should encourage, the school have to encourage consistent study habits and improve the students' attendance. And also some of the factors that we have seen, even though they don't have a strong prediction, they have somehow influenced the students' study hours. And lastly, we would say that through the data analysis, and visualization, we changed the raw data into meaningful visual result, and we can further discuss this to give evidence-based decisions. Thank you for listening.
Thank you for the great insights regarding study habits and sleep patterns, how it's important. Even though we know this as a factor from experience, but then putting it in data and clarifying it is quite actually interesting. And thank you a lot for that. If there is anyone who would like to add comments to this, it's always open. But otherwise, we can move on to the next presenter. Thank you, Hermela and the team. So I'm going to Mako. Mako, thank you for being on stage and ready. I've put you on stage. Hermela, you might leave the room for others to join. Mako, you have 5 minutes. Please set a timer. When the time comes, it's very hard for me to interrupt you as you're presenting, but let's make it critical. Necessarily, you don't have to consume all the 5 minutes. Just if you have presented well, then you might as well leave the time for others to present. Thank you, Mako. Over to you. You might as well leave the time for others to present. Thank you, Mako. Over to you. Mako, I think you're also opening the YouTube. Please close your YouTube so that we don't have an echo.
Okay, good afternoon, everyone. My name is Mbakwe Nchizibute. I am representing Group 5, and our title for the project is Screening Time Analysis, Understanding Digital Human Behavior. I will dive right into our slides. So, our topic comprised of data that lists all the social media apps, that is WhatsApp, Facebook, Instagram, and it reveals the number of minutes spent using these apps per day and the number of times people unlock their phones in an attempt to view or use these apps. So our data analysis began with an inspection. As you can see over there, we simply listed the rows and columns for each table. So we had 3 tables. The first one was the app details, app ranking, and overall usage. And then we dive right into explorative data analysis, where we described the numerical columns for each table. And then that helped us to look for outliers. And then we also did an analysis where we checked for missing dates. So this is our first plot, where we've plotted an overall device trends that encompasses for all 4 apps. I've included a plot where we show the usage in minutes. That is the blue line graph, as you can see on the far left, to read off the values. And then the number of unlocks for all 7 apps, as you can see on the right. And then the dotted curve that's in the middle it represents the 7-day average for the unlocks and the usage. That is per day for 7 days. And then now we have a more detailed direct app comparison where we compare the number of usage in minutes of Instagram versus WhatsApp. So this is the number of minutes that people spend on WhatsApp versus Instagram. And we can see that towards the end of the 7 days, Instagram remains fairly low, whilst WhatsApp remains fairly high. So, in conclusion, we have that WhatsApp. Most people spend more time on WhatsApp than on Instagram. And then over here, I have a subplot of further analysis, of further direct app analysis of usage of Instagram versus WhatsApp. So on the first two graphs, we can see that WhatsApp continues to maintain a very low number of. I mean, Instagram. Sorry, my bad. Instagram shows a very low number of usage for the last few days, whilst WhatsApp remains up high. So that is for usage, notifications, and the times opened. And then over here, I have a bar graph that ranks all 4 apps and counts the number of times each app appeared in each rank. So as you can see, WhatsApp remains the most occupied and the most useful and the most in which time students or people in general spend their time on. And then over here, we've included a heat map that is to show the intensity of the frequency of either usage, but in this case, oops, let me hide this. The usage of the apps in terms of intensity over the weeks. So you can see that the lighter that is, that means the lower the intensity. And then the darker means the higher the intensity of the frequency of rank 1 apps by the week. So we can see again that WhatsApp is the one that has the most intensity. And then here we have a correlation matrix that is combined by a heat map, again showing the intensity of multiple direct comparisons. So total usage compared against WhatsApp notifications, Instagram notifications, and specific usages, unlocks, and notifications. And then over here, we also have another 7-day analysis of notifications versus total usage for the day of the week. So we continue to see that over time, Instagram usage plummets, and there's a red dotted line that shows when this takes place. So for majority of the first few days, usage is high, and then for the last 3 days, usage is low, where Instagram has the lowest usage, followed by WhatsApp, and then and then total usage. So these are our key findings. We found out that the total screen time was 6,181 minutes over 27 days. The average daily usage is 229 minutes per person. That is 3.8 hours. And then the WhatsApp dominance is 99 minutes per day versus Instagram's dominance, which is only 31 minutes per day. Then there was a major behavioral shift. Instagram usage dropped 96% after September 12th. Thank you for listening to that presentation.
And in case of the sampling case, I think I'm not sure which place you directly take on because from different places we may get a different kind of analysis. So you may need consideration of those things a lot. Besides of that, you already told us about the period that you already checked. But which area will each of the activities will reach on peak point may require also further analysis. But we all allow you to study because it happens. Try to include Facebook, Zoom, and some others. I also love it. So continue with this effort. I hope it will be a very nice project very soon. Thank you.
Thanks a lot for the good presentation. So we might now proceed to group 21, that's Isakor. So Isakor, over to you. I think it's group 20, I'm sorry. So the next presenter is going to be, I'm going to see only the last shot. So group 21 is Kadus. Kadus, please join the StreamYard. We can hear you, Sakori. We can also see your presentation. You might with your presentation.
Okay, so thank you for the chance. My name is Sabra and I'll be presenting the project that is made by Group 20, which is titled Next Word Prediction. And it actually uses tree data structure. So the core concept is basically similar with the keyword in our phone. That suggests a word while we are actually typing. When it comes to the system architecture, we actually have four main components. The first one is interactive loop that makes the user insert the text inside the source code. We have a source word storage, suggestion logic, and finally dynamic visualization that we can actually see the prediction visually. So when it comes to the libraries that we import in the source code. We just used three libraries that we have seen in the training session, and additionally, we utilized standard libraries to make the execution more interactive. So let's us see the demo and see the execution. So this is the passage that we actually take as a data set, and when we run the code, a terminal will pop up, and there is a section dedicated for the user to insert any text. For example, let's say, and this will result in the window that makes the user visualize the next probable word that is suggested. So the other thing is, if we insert a word that is out of the scope of the data set, for example, like this, a text will be outputted, which says no data set match found following word. And if we want to exit the execution, we just write quit and press enter, then the terminal will stop doing the execution in the source code. So this is all about our presentation. I hope you like. I hope you like the presentation. If you have any question, you can raise. But if not, this is all about the presentation.
It's great to hear what you have done. As most people are focusing on developing apps, but these types of works are very critical for the development process, because actually it's suggesting the word typing, and which is actually the fundamental or the very important section for the app to be usable. And if we have this for the Ethiopian words, like whenever we type Amharic, this could be quite interesting, and it's something that's very appreciable. So that's my good words, and thank you. But this is just the beginning. You might as well develop a lot about this project. I get it.
For me also, thank you very much. It's very nice presentation, and I love that you address such kind of programs, especially data analytics taking on Python by itself. It helps a lot, especially to address those who need to study in further to grow their skill and knowledge in the programming language is very helpful. And continue with this effort. It's my appreciation. Thank you.
Thank you. So the next presenter is going to be Usted. Usted, you're on stage. Which group are you?
Hello, can you hear me?
Yeah, I can hear you. Which group
Okay,
are
I'm
you?
group 17.
Group 17. Okay, you can go
Yes.
on.
All right.
Group
Give me a
17.
moment.
You
Okay,
make your presentation full
so
screen.
you can you see my screen?
Yes, can you make it full
Okay,
screen?
I should make it full screen.
Yeah, so that we can see it better.
Okay, hold on.
So as you start your presentation, we'd appreciate to know from which part of the world that you're presenting and also the city of which you're presenting. That would be great. Thank you. Over to
Okay.
you.
I'm failing to make my presentation full screen. It seems like this is as far as as it is going. But hold on. Can you see it full screen now? Hello? Hello?
Yes, we do. It's not full screen. To make it full screen, to you need to click on that full screen button next to the zoom button. Do you see that?
Okay, hold
Top,
on.
the bottom left, bottom right, bottom
Bottom
right.
right.
Go on, go on, go on, go on, go on towards the right, bottom right. Next to the zoom button. Okay, uh, you can just go on.
Okay. So we're presenting on data analytics visualization project. So this is regarding social media, sleep, and student mental health. So the question we asked ourselves is, to what extent do average daily social media usage and sleep duration influence students' stress levels and mental well-being? So this test was carried on. Well, we obtained the data from Kaggle, and this data was obtained from 5,000 different students. And we use NumPy, Pandas, Matplotlib, and Seaborn. And so what we'll cover the dataset and methodology, well, how the data was collected, cleaned, and prepared, the usage and sleep versus mental health, well, the correlation and regression findings, and the combined effect, well, what happens when high usage meets low sleep, as well as the conclusions and recommendations, what students, parents, and institutions can do. So, firstly, we had 5,000 student responses, as I mentioned. So, we analyzed the average daily hours, sleep hours per night, daily unlocks, study hours, and physical activity hours. So, the outcomes were, we got the stress level, which ranges from low to very high, where low is 1 and very high is 4. Yeah. And we also have the mental health score from 0 to 10. So we used NumPy for regression, Pandas for grouping, Matplotlib, and Seaborn for visualization. So the question is, do usage and sleep actually move the needle on stress and mental health, or is the link weak and incidental? Because sometimes correlation doesn't equal causation. So the first hypothesis is that higher social media usage is associated with higher stress and lower mental health scores. And the second hypothesis is that longer sleep duration is associated with lower stress and higher mental health scores. Well, this is from what we would deem common knowledge, or what we think is the right thing. So we have the correlation matrix for every lifestyle factor correlated with mental health. So as we can see, the stress levels have, yeah, quite high quite a high correlation with the average daily usage hours, as well as the daily unlocks having a higher correlation matrix with the average daily usage hours. Yeah. So the daily unlocks correlate highly with the stress levels. The sleep hours per night correlate highly with the mental health score. The average daily hours, the study hours, not as much. The physical activity hours, not as much as well. Yeah. And then,
Um, I'm sorry, but you're stuck on the first slide.
oh,
Let
I'm
me
stuck on
see
the
it.
first slide. Okay. Okay. Hold on. Can you now see everything?
No, actually,
You can't see the second slide?
no.
Okay, hold on.
Okay, but yeah, this way it's better.
Let me try
How?
again.
Yeah.
Can you see the screen?
Um,
Hello?
yeah, we can see your screen now.
Okay, okay, I'm so sorry about that.
Yeah, you can go on clicking the slide that you present in remaining with just 1 minute.
Okay, so as usage climbs, mental health falls, and there's a strong negative correlation, which is, well, 82%. And as we can see by the graph, as the average daily hours increase, the mental health score decreases. So students using social media 6+ hours a day on average, well, they average 4.98 on mental health versus 7.98 for under 3 hours a day. And then more sleep, better mental health, with a strong positive correlation of 0.77. We can round that to 80%. And students sleeping under 6 hours average 5.11 on mental health versus 7.64 for those getting 8+ hours. And we used linear regression. However, we could have used random forest regression as well. Yeah, because it was, I think that's more in line with what we were doing, but given the time constraints, it would have taken a bit longer. So stress rises in lockstep with usage, and short sleepers report far higher stress. So the mental health score by usage, we have low, which is less than 3 hours, which is a high. Hold on. Stress rises. Okay, yes. So, uh, okay. I think on the graph on the left, this graph right here, I think it meant to say stress, because the stress should increase more for people who have lowest hours of sleep, and the mental score on the right, the mental score increases as the amount of sleep increases. And then we have the two factors compounding each other. We have the best profile is with a score of 7.92. We have low usage hours and long sleep. So low usage, less than 3 hours, long sleep, 8 hours. Yeah. And then we have the worst profile, which is high usage and short sleep. Oh, okay. My bad. On the previous slide, it was mental health score by usage. So the higher the usage, the lower the mental health score. And then we quantified the combined effect. So we used multiple linear regression with NumPy least squares, predicting each outcome from both factors at once. So with the mental health score, we had a usage coefficient. We had a usage coefficient of minus 0.44 per hour, with a sleep coefficient of plus 0.32. Stress levels are 0.39 per hour and minus 0.26 sleep coefficient. Yeah. So reading the coefficients, each extra hour of daily usage is associated with minus 0.44 points of the mental health score, holding sleep constant, while each extra hour of sleep adds back about 0.32. Together, two factors explain roughly 70 to 70% of the variation in outcomes, which is very high for self-reported
Excuse me,
variation.
Stan.
Okay.
As I would like to enjoy your presentation, but we do have a very strong time limitation as there are a lot of groups to also see. So we might have to stop your presentation here. We're going to see the details of all the works that you have done. It's
Okay.
excellent job in terms of realizing social media and also the sleep and stress correlation, especially. And also you've done a regression
And that's something very great to see. Thank you. Which group are you, by the way?
Group 17.
Group 17. Thank you,
Yeah.
Sted. And yes, from which country are you? Megada is requesting actually.
Botswana.
Botswana. Okay,
Yeah.
okay. Thank you, thank you. Maybe Nagada could have a few words. Okay.
Okay, thank you. It's very nice presentation. I only advise you to add about age category because it's one of the main issue when you are working on the data analysis. As you are addressing student mental health and sleep, you need to consider of those age categories. And it's good if you were introducing as I had when you are starting for all of you. More than that, I do not have anything to say. It's very nice and well done. Thank you.
Okay, thank you so
Thank you,
much.
Sted. Thank you, Sted and the team. So from now on, I'm going to put anyone who have the presentation slide and the presenter ready. So that's group 11. Can you hear me?
Yes, I can
No.
hear you. Am I audible?
Yeah, excellent. So you might proceed to your presentation. Please use your time effectively, or as well, I might have to stop you. Okay, over to you.
Okay. I am Don Masata Bengwa. I'm representing Group 11 from Botswana, and we will be taking you through an analysis on how study time affects student performance. Okay, so first we have to understand that at the core of data analytics is problem solving. It's turning raw data into something that can help businesses or people in different industries to be able to come up with strategies and all the likes. So our presentation objectives are to give you a topic overview, to discuss our findings and the visualization and interpretation of findings on our graphs. Now, the topic overview is that our project focuses on discussing how the hours taken to study affect students' overall performance. And our key variables which we used are the study time in hours, which is the independent variable, and the GPA, which is the dependent variable. And I'd also like to note that when it comes to variables in data analytics, there's what we call the case of dimensionality, and our group, and the reason why me and my group decided to narrow down the variables was so that we're able to zone in on the specific variables to be able to understand how they are related more and what we can infer out of it. And then our discussions of findings are that the analysis found that on data collected, the two variables are positively related, which means that when the study time hours increase, so does the performance or GPA of the student. And the goal of the analysis was to assess how the study time affects student performance and to see if more studying hours led to better performance or a higher GPA. And the findings did confirm that indeed more study hours do lead to a better GPA. Now, the first graph that we used was the histogram, and we wanted to also explain why we used that particular graph or why it fits the data. So the histogram with a kernel density estimate was utilized to place emphasis on the frequency distribution of the variables, which helped identify the spread, range, and skewness of the data. The KDE curve was added to help provide a smooth estimate of the distribution, which aids in an easier analysis and use of analyzed data. And the findings on the histogram was that it showed that the distribution of students' GPA values, most of them had between 1.5 and 3.0, which indicates that the average GPAs are the most common, and the very low ones fall between 0.5, and the very high ones are above 3.5, right? Which means that the GPAs are really less frequent. And then we also have the scatter plot. Now, under the scatter plot, the graph was used to place emphasis on examining the relationship between two continuous numerical values. The addition of a regression line makes it easier to see the overall direction and strength of the relationship to further support our statistical analysis. The scatter plot was to show the relationship between weekly study time and GPA, and the upward sloping regression that was noted was done to show that there's a weak positive correlation, which means that students who study more generally tend to have slightly higher GPAs. The positive relationship shows that when one variable goes up, the other also goes up. So when students study more, then that means that the GPAs are better. And the widespread of data points shows that the study time is not the only factor affecting GPA, which means that there are other variables that could be affecting the GPA besides the study time. And then the next one we used to give you a more holistic overview was the joint form, and it was basically utilized to bring emphasis on the distribution of each variable and to help us identify trends, correlations, and outliers. And the graph, obviously, like I said, it shows a weak positive correlation between weekly study time and GPA. And there's also another upward regression line, which shows that as students study more, then the GPA also gets higher. And the last one that we have is basically the correlation heat map, which was basically used to give you a quick overview of what is actually going on. And it basically indicates that study time and weekly it basically shows you the correlation coefficient of the study time and the weekly GPA, which is 0.18, which indicates a weak positive relationship. This means that as study time increases, GPA tends to increase slightly, but the relationship is not that strong. This means that these variables are not tightly related to each other, which also points back to what I said to say that there might be other variables besides study which also affect GPA, but it doesn't take out the fact that this is also a contributing factor. And then the one values on the diagonal represent a perfect correlation of each variable with itself. In summary, our data analyzed to show insight that students who studied for more hours are most likely to perform better. It also utilized various visualization tools to bring emphasis and highlight unique features of that data findings. We used scatter plots, histograms to try and bring more detail to certain trends that we saw in the data that we're analyzing. And the recommendation, because data analysis is all about also coming up with recommendations to say, we have the data, but what do we do with it? Hence, our recommendation on the basis of the data was that we would encourage students to study longer and also possibly explore testing other factors that affect study performance to be able to get a more holistic and accurate picture. Thank you.
Thank you. Once again, what's your name, please?
My name is Dawn Masata Bengwa.
Please, once again.
Pardon?
Pardon, please. Oh, Duan, right?
Yes,
Duan.
Dawn. Yes.
Okay, Dawn. Duan.
Yes.
Thank you very much. It's very nice presentation and well done. You try to consider the time with that of the study time with that of the GPA results that we get in our school. It's a very nice presentation, and you also told us that there are some other things that need to be considered. Maybe you are going to work on it a lot in the near future. That's what I felt. There are some things that we need to consider that affect our GPA grade in our schools and universities. It's very nice presentation. I love the heat map and everything that you show us, the histogram. Zanas, well done, and thank you.
Thank you so much.
Likewise. It was a great presentation. Thank you. Thank you. I think you're group 11, right?
Yes, group 11.
All right. So thank you. We might now proceed to the next presenter. And that's going to be who's ready. We'll only be sharing anyone who's ready. Anyone who shares the screen to the group in the StreamYard would be shown. It goes from group 11, but Down, I might have to. Down is not here. Okay, Kadus, I have you here. Kadus, I've added you to stage. Can you please start sharing your screen? Kadus, share your screen. Anyone who shares their screen and also is in the StreamYard, I'm going to make them the presenter. Okay. So I've made you a presenter feed and also add you to stage. Okay, you have, can you hear me? Hear me.
Hello, everyone. Good morning.
Good morning,
Hello.
good afternoon. I don't know
Good
which part of the world
guys.
that you're in.
Yeah,
Okay. So explain which part of the country that you're in, the city, and also your group, and then you can proceed.
okay. I am Filimawit, and I'm from Ethiopia, and I'm from Group 19. So, as the Infonovia technology for 3D data analytics and visualization training project, we have selected the project title for the students, exam performance factors. So we are going to see that factors affecting students' exam performance. So in data analysis approach, we understand how gender, parental education, lunch type, and test preparation influences the academic outcome. So for the problem statement, as we see, educational institutions say that students' factor for the exam performance is only for their knowledge or for study, but there are also factors that affect the students' exam performance for the pre-education or the test preparations and lunch types also. So we will explore it. So the academic performance is influenced by many factors beyond the students' ability alone. So the project analyzes that students' exam performance dataset to understand how different factors affect the students' score. The study focuses on the gender, the parental level of education, and the lunch type and test preparation course completion. So the dataset we picked from Kaggle. Originally, it was no missing values, so and we intentionally added for up to 8 students with some null value to show the data cleanings. So as a standard, so we used student records for 1,000 and 1,000, and the variables analyzed or the columns we used for gender, parental level of education, lunch type. There were 8, and the exact subjects are 3, which are writing, reading, and the math score. So as we proceed to the dataset variables, the dataset contains about demographic backgrounds and exam results, and additional to average score, with a mean of 3 subject scores, which are maths, reading, writing scores, and the gender for students' gender, male or female, and also the race or ethnic, which is for a group category, and the parental level of education, which is undergraduate, master's, and high school level of students. So as a parental level of education, also the lunch type, which are a standard lunch or free or reduced lunch types, and also we used the test preparation course. The course was completed or not. So as a data analytics, we use data cleaning and preparation. So before analysis and the data is checked and prepared using pandas. So first we look the data and then we check the structure and is it data frame or is it series, and then we check the missing values, the duplicate rows, and also we create average scores. And as I said originally, there was no missing values and also no duplicate records detected. we intentionally added to see that. So the test preparation and gender effect for the test preparation given was when we see that using the average score for the test completed and for who hasn't completed, already there was the completed percentage for 70 average score and the percentage score for the 60% for the not completed the test preparation courses. And also for the gender, according by the average score for the female, 70% of females shows that the highly average scores and the almost 65 average scored for the male. So parental education impact, we use it for master's degree, bachelor's degree, associate degree, and some college and high school degrees. So students with higher parental education level generally show that the higher level of performance. As we see that the effect of parental education on the student performance is, for example, for the master's degree, they achieve a highly average score, which is almost 75. And for the students in high school, they score average, which is low as 63 or nearly 63. Oh, sorry. Also, for the lunch type and socioeconomic factor, for the students who eat standard and for their free or reduced are also have effect. For example, as we see that the standard lunch type given has average score 70, but for the reduced or for free students who taken the lunch for 60. So it has a factor with a lunch type on the performance of students' exam. And also, as we see that the math score for the number of students distribution, we are showing that from the 60 up to 80, maths scored a high number of students. And also for the gender and math score, we see that the female and male. So the female students has low than the male students. Almost both students reach the 100 score, but when we see that the average or mean for male students score the 65 nearly, and also the math score for gender females is we see that low. And also test preparation course versus the math score. The test preparation course for completed students have the mean of 65, but also for the who hasn't completed is or taken none course is for 63 almost. So also the students who doesn't take the test preparation course score a low, almost 0 score on their math score test. And also the lunch type we use it for standard student, the students eat their standard lunch type have scored the 65, which is high than the students who freed or reduced their lunch. And also for parental education and the math score we use that we can see that the master's degree is high math score than the others. Also the for high school students or also some high school students score almost 0. So it has a factor for parental education on the performance of maths exam scores. And also the race is for groups, we can see that the highest risk group E has a highest median, almost 80 of the male all over these groups, and also on all types of the groups or races, the males are scoring high at maths. And also we used the pair plot for the maths score, reading score, and the writing score. As we can see that the reading score and the writing score already, the scatter plot is tight. It means that they have a relationship, and as the reading and the writing score going to up. And also we see that the math score are for the females is low, and also for the males are higher than the females. And also we but for the reading score and for the writing score, the female gender are higher scoring than the males. And also we see that the relationship between the maths, reading, writing on average, we see that the scatter plot and correlation heat map have the strong positive relationships on all of the subjects. For example, the reading and writing scores have the highest correlation 0.95, while the maths correlated with reading is 0.82, and also for writing is 0.8. So the correlation between the students is already. And also we find that the test preparation matters because the students who completed the test preparation have scored higher than who doesn't take. As we see on our data, the 73 on average scored who take the the test preparation completely. And also strong student subject correlation. The subjects each other has the correlated for reading and writing have highly strong relationship, which is the factor 0.95 with each other. So as students improve their reading and writing skills, it's related together. And also background influences the performance. Students who study in different types of education levels can influence, and also students who serve their lunch time and who doesn't eat have influence on the academic performance. And also the average score as a metric, average score provides a useful overall measurement of the student achievement across all over the subjects. So we recommend and conclude that based on our findings, we propose the following actions and insights. So we encourage to educational institutions have to encourage preparation programs. So students should actively promote and facilitate participation in test preparation courses to boost students' score. And also they have to provide the academic support, offer for a targeted academic support for students who need additional training and assistance as you are for this who doesn't have disadvantage backgrounds. And also the collaboration between parents and schools have a great learning environment. And also balanced subject preparation for all subjects have to be prepared consistently and effortfully for a strong interdependencies between reading and writing math. So this project effectively demonstrating the power of data analysis in eliminating the various factors that influence student exam performance through the careful data cleaning, insightful visualization, and through analysis of various relationships. We pinpointed critical elements linked to academic science. So we conclude that the factors that affect for the student exam are not only for students' ability alone, but also there are for gender, test preparation, and lunch types. Thank you for listening to me. I'm finished. Hello, thank you for listening to me. This was all about our project for group 9.
Okay. Um, it was a nice presentation. Thank you for for the presentation. Thank you for your presentation. It was a good insight that you've given us regarding student score and the different things that are actually affecting the scores. So maybe I also pass it to Nagenda for some.
Okay. Thank you, please. I think you addressed lots of issues actually. And within that, I would say I would appreciate actually your project is very nice. And it requires also a lot of data to analyze those issues because you touched a lot of insights in it, especially what kind of support mechanisms that we need, what kind of programs do we need to address to adjust the score result of students. You showed us different analysis through age category, through the levels that we are in, high school, university, master's degree. So those things vary, as you said, in different ways. Like if someone who scored in mathematics higher, it does not may mean like he can also score in some other areas. So addressing such issues through using different data analysis mechanism requires its own system. So I would say thank you very much and appreciate your project. And you may need to work a lot on it also. Is my comment actually. And you already show us a lot of data visualization techniques using Python program. So I love it also. So thank you very much from my side. Appreciate you a lot. Thank you for this.
Thank you.
as we have a lot of presenters, but we're going to set up a time for the rest of the presenters to present tomorrow. Uh, okay, Kudus, over to you.
Okay, am I audible? Okay, now today my team, Group 21, and I, Kudus, has presented a presentation about social media impact on mental health. Um, Now, without further ado, let's dig in. First, we have presentation agenda and structure. We have four structures: demographics, rest and restoration, academics, and psychological dimensions. Next, we have the daily social media hours, distribution, and age insights. There is about 4 and 7 plus hours made wasted on social media by people, and the main daily average is 4.5 hours. The median daily use is 4.5 hours, greater than 100 max frequency. So when we go over to the next slide, we have daily social media hours by gender consistency analysis. Daily social media, virtual identical distribution across genders. Mostly the male is 4.5 hours, the median is 4.5 hours, and the female is 4.4 hours. And this shows that the male and female, there are not much big difference between those two usage of social media. And when we go over to the next slide, we can see that the sleep hours versus the social media hours. People mostly use their sleep hours at night time for social media. We can see that 1 up to 3 hours used from sleep time is low, 3 up to 5 is medium, and 5 up to 8 hours wasted on social media during sleep time is high. As you can see from this graph, you can understand it. Next, we have most popular social media platforms for teen cohorts or teenagers. Mostly teenagers use Instagram and TikTok mostly for social media purposes. And both segments are not mostly found, but they are also found. Instagram users 412, TikTok users 318. You can imagine, like, teenagers using this amount of TikTok and Instagram. And fluctuation in students' academic performance, grade trends, unrestricted access fuels high fluctuation. If you're given Instagram or TikTok, any social media, without unrestricted access by your guardians or parents, you can lose your academic greatness. The This shows that 90% is the peak that a student has gotten, and 22% is the max score delta. So on exam one, we can see 75%, 80%, 68. You can see the fluctuations between the grades because of unrestricted access. Now we can pass to depression prevalence by age group, clinical assessment. Dangerous risk spike at age 15 because mostly students at age 15, they use their time on social media alone. They're not socially communicable at that age. They spend a lot of time alone, so there's a high probability that the students may be depressed. There is 4.4% peak prevalence and 15 vulnerability age. It is the vulnerability age 15. And when we go to the next slide, we have addiction level by sleep quality or pathology triggers. When you are addicted to this social media, you can lose your sleep because addiction in social media is very dangerous for people who cannot control themselves. Poor sleep directly feeds addiction. Analyzing average self-reported platform addiction scores reveals a direct reciprocal relationship with physical rest quality markers. And we can see that 5.7 poor sleep score and 5.4 long sleep score. You can see that the long sleep score have less addiction and the poor sleep score has high addiction. And the next one and the last one you can see is daily social media hours versus anxiety level. Um, the anxiety level of a person increases as long as he spends more time on social media. This is shown by 0.34 persons and p less than zero point 0.1, the person spending more time on social media and not with his colleagues or any other people. The greater social media hours, the greater the anxiety level. And that's all I want to say for today. Thank you very much.
Thank you for the precise presentation that you have given us, Idus. It was very good and good to actually stress on the social media usage and how that could actually challenge uh, the normal lives that we have and creating anxiety and everything. So thank you. Maybe I'd proceed to Nagada if you have a few words to say.
Thank you very much, Kados. Well done. You already addressed a lot of issues in it, like sleep, anxiety, addiction level, and those of kids who are in the age of 15, they reached mostly peak point. And I feel this study will help a lot. And please continue with the study. That's what I would say. And thank you very much. It's very nice and clear presentation and analysis. Thank you.
Thank you for giving me this opportunity.
Thank you, Kadus. Thank you. So we now proceed to
Yeah, thank you all for being a part of this program. So we almost addressed almost all of the groups. You didn't? Okay.
So the thing is, we have remaining groups that haven't presented, but we decided to actually proceed it to tomorrow in the afternoon. We're going to start at 2 p.m., just the time that we started today, because there is a lot of you still remaining. So we wanted to finalize today's section and move on, and then we can continue tomorrow. Yeah.
Perfect. So we can finalize tomorrow. Yeah.
So in that case, so today maybe we have Tio. Tio, you might, if there are a few words that you would like to say regarding the training, Tio and the team, I have put you on stage. So this Tio was really supporting you, especially from Botswana and the Botswana Center in Orange, in the digital center. So if there are a few words that you can say, over to you, Tio.
Hello.
We can hear you.
Hi, Ledetum. Still, I'm here with our Still, I'm here with our Sentinel.
Yeah. So we can hear you, I think.
Okay, now I'm overtaking will wrap up the session via other channels. Yeah, not to waste any time. Afternoon, and just wanted to extend a huge congratulations to everyone that attended the
Tio,
training.
there is a bit of an echo Maybe if there is another device that's speaking.
Not here. Can you hear us properly? I can switch to headphones.
Somebody switch off. Let me just switch it off.
Not here.
Yeah, I think it's better now. Can you speak?
What about now?
Yeah, it's so much better. We can hear you now.
Are you still getting feedback now?
Yeah, we can hear you so much better now.
Just a second.
Hello, maybe Tio, if you're speaking, you're on mute.
Can you guys hear me?
Yeah, yeah. We actually lost you. Tio, you're actually on mute.
Hello, hello.
Hello, we can hear you over time.
I'm not sure what the issue is now.
Uh, I'm not sure if you can hear us, but we can hear you.
Hello.
No, we can hear you. Hello, Bakan. We can
Yes, can you
we
hear me
can
now?
hear you. Yeah, we can hear you. Great.
Do we have feedback still?
Yeah, no feedback. It's clear.
Okay. Thank you. Apologies for the technical glitch. Just wanted to thank everyone that made time to attend the training. A huge thank you to Infnova, the government of Ethiopia, Ministry of Technology. You'll excuse me if I'm not mentioning them by the right names, but we really appreciate the opportunity to join you on what has been a very impactful training. The buzz here at the ODC in Gaborone has been amazing. The talent is clearly enjoying what it is that they've been learning, and we're excited for their next chapter, really. So the challenge to us would be what to see to follow this up, to make it more meaningful, and hopefully for some of you that have done the training,
you'll go on and actually utilize this in your businesses, in your entrepreneurial journey, in your schooling, and just personal development. And we hope that the data visualization course with Python will have a long-lasting impact in your lives. From us at the ODC, we continue to be open to support you. Please, like I said to some of you that are here in Gaborone earlier today, feel free to come by, use us as a platform, go out there and use what you learned around data to exploit information in your community and build real value for your people, your family, your communities, yourselves, and the businesses that you operate in. Special thank you to Theo and the team here for organizing and coordinating and supporting all of the people here. Leader to you, a hero. I don't know how you do it, 8 to 5 every day, and you still manage to see it through with such grace and poise. We really admire the work you put in, and I believe everybody here can agree that you've been of great help and value. We really thank you for the work you've put in, and looking forward to more collaborations in the future. Thank you.
Thank you, thank you. Thanks a lot for the appreciation and also the effort to support the students around Boroli to, I mean, giving space, supporting, and everything, and also Tio for giving all you got for your students. This was really amazing, and for all the students who have done a great job in learning all the 3 days, day in, day out. Especially some are just quite beginners who have transformed into visualization now using Python, and that's really excellent. And I'm really happy to see the transformations that are happening here, and also which is very critical because on the time that we live, data is gold, data is diamond, data is everything, and having a great insight in the data is something very critical. So that's what our students have been doing, and I really appreciate the efforts that all the students have done and keep on doing this in for goods of the society, for a better job opportunity. And if you actually have startups and works that you do on your innovations, please make sure that you integrate data. If you're probably working on app development, make sure that every decision that you make is actually integrated into data so that you have a better usage turnout. And yeah, that's what I wanted to say. So for some of the groups that are remaining, we'd resume our presentation tomorrow, the same time at 2 p.m. And lastly, on Friday, in the afternoon at 2 p.m., you'd have your final exams for the course. Make sure that you study and cover most of the concepts that we have been learning, because it's going to include pretty much everything. So make sure that you revise well. And on Friday at 2 p.m., we're going to release the exams. You don't have to join online for the exams. Just be on the groups and the links would be sent out. But for tomorrow, the groups who haven't presented, please join back. And also other fellow students, you can join back and listen to your fellow friends and fellow groups presentation. Yeah, that's my word. Let's move on to the supports. Betty, if you have a few words you want to add. Okay, so tomorrow we'll have our closing sessions. But for today, I think it's already 5 and we've been here for the whole day. So you have a great evening. I'll see you tomorrow in the afternoon. Thank you.